All right. So we finished the first example yesterday, and we're going to continue on with this multiplication and multiplying these together. So if we want to find the product of these two things, we're going to multiply the numerators together, and we can multiply the denominators together. Yes? So what we're going to be multiplying as well, on the top, we're multiplying the numerators together. So we would have our 6 times 9. X squared and x to the 5th are like terms, so they'll be multiplied together. And then we have y and y squared, because those are like terms. So those are going to be multiplied together. Now the denominator, well, we have our 3 times 2. But we only have one x, and then we have y cubed times y. So we're multiplying our like terms together, yes? Now, is there anything that says that we can't simplify at this point here? I mean, if I simplify here or I simplify later, it still gets simplified, yes? So would it be easier to simplify now or simplify later? We can do it now. It really doesn't matter which one we do. Because if we can see something that simplifies now, we can simplify it now. Because if I look at this here, well, wouldn't these two y's simplify out? Because anything divided by itself is 1, yes? So if I wanted to, I could simplify these out right now. Or, well, hey, 3 times 2 is? Well, that would simplify to 1 also, wouldn't it? So if I can see things that I can simplify now, there's no reason to simplify later. So, because if we can simplify at this point, well, we would be able to simplify it later also, yes? So we could do that here. Is there anything else we could simplify? I mean, there's with the y's and the x's, but that doesn't kind of simplify out pretty easily, because we can do it. Well, one of these x's would simplify with one of these, yes? So if I mark this out, well, the 2 becomes what? Becomes a 1. And what can we do with the y's? Well, these 2 would cancel out with 2 of these, which would give me a 1. What's left? On top, we have what? Well, 1 and 5 give me 6, yes? What do I have left on bottom? That's it. That's what we have to do with this here. So, I mean, we could simplify here. We don't have to multiply everything together and then simplify. Because if we can see what simplifies, go on and do it. So if we multiply on top, well, we'd have 3 times 6 times x to the 5th times x times y squared times y squared. Because I'm just rearranging them so we kind of have them in a like pattern. Now on bottom, we're going to have 8 times 9 times x times, times, yes. So do we want to do what we just did with simplifying, or we want to do what we did yesterday? You guys like what we just did, kind of canceling things out? Yeah, let's do that. And that's some of the times when I do it is how I look at it and see. Well, 3 and 9 both have a common factor of 3, yes? So if I simplify that, the 3 becomes a, and the 9 becomes what? A 3, yes? Because if I simplify that factor out, I have 1/3. So I kind of mark it out and kind of rewrite the number in just so I know what it is. Well, wait a minute. What about the 6 and the 3? Do they have a common factor of 3? So what? The 3 would become a, and the 6 would become what? 2. Because when we pull it out, 6 is reduced to 2, and 3 is simplified out, yes? Any other common factors with our numbers? 2 and 8, yes? Because the 2 would become 1, and the 8 would become what? 4. So what's the only number left? Besides 1 is 4, yes? So if we're simplifying, well, we'll have 4 on bottom. Questions on this here? And if you wanted to double check and make sure, because we could take a calculator and do 3 times 6 over 8 times 9 and hit enter, and it'll give us 1/4. It'll give us the 4 on bottom. Okay, let's look at our variables. Oh, hey, x and x here and here, yes? Go on and mark those out. Those are nice. 1 and 1, gone. What about the other x's? 3 on bottom, 5 on top. Well, these 3 will cancel out with 3 on top, which doesn't give me a 5 anymore. It gives me a 2. With what? How would I rewrite the y's on top? Because y squared is y times y. So the 2 y's on bottom will cancel out with one of the y squareds. Is everything that's similar on top and bottom gone? Okay, let's see what we have left. So on top, well, it's 1 times 1. Well, then we have x squared, y squared. And the only thing left on bottom is 4. So that's it here. Questions on this here? That's all we have to do with this here. We good with this here? The y's here? Yeah. So if you're not too sure, I'll put this back. Times y times y. So we have this here. So this is the point. We were good up to this point here, yes? Okay. Now what we can do is, okay, look at what's on top. Well, 1 times 1. Well, we have x squared. Y squared times y squared would be y to the 4th. And then we have 4y squared. Because at this point, I'd factor out what you can see and factor out. So if you're having difficulty with that, just multiply them together and let's see. Okay, well, I do have that y in common on top and bottom. And whenever the bases are the same and we divide, we subtract the exponents, yes? So x squared is going to be left alone, 4 is going to be left alone. So when we subtract it, it would be 4 minus 2, which is 2. Is it bigger on top or bigger on bottom? Which one has a bigger exponent? Top, so it stays on top. And it'd be y squared. And that's it. So we can do it that way also. Does that make sense? Because I could also say, okay, y times y is y squared. Well, hey, these are the same. So they do cancel. So this way does make it a little bit messier, but it's getting the same process done. So I would figure out which way you like better and do it that way. Okay, we ready for this here? Factoring again. Factoring, factoring. Three x is the only thing we don't have to factor because, well, there's no way to factor 3x. Okay, let's look at the top one here. 3x minus 3x squared. What can we do with it? Was there a greatest common factor between those two terms? And that would be what? 3x. So we can factor 3x out of this here, and 3x factored out of 3x would be 1 minus 3 factors out completely. And if I take an x away from x squared, I'm just left with x. Okay, let's look at the denominator, x squared plus 4x minus 5. We'll have two sets of parentheses. Since 5 is negative, the signs are positive and negative, opposite signs. Factors of x squared are and x. And the factors of 5 are just 1 and 5, yes? Would the 5 be positive or negative? Positive, yes. Because I look at the middle term is positive, yes? So most likely I want the bigger number to end up being positive. Now because we don't have any numbers with x, it's really just going to come down to the constant terms. And if we do check this, this does work. Because if we checked it, we would have 5x minus x, which would give us, not negative, it would just give us positive 4x. This would work. Now the last thing to factor is this one here on top. Since the 20 is negative, the signs are opposite. The factors of x squared are and x. Now the factors of 20 are 1 and 20, 2 and 10, 4 and 5. So which one do you think would be helpful to have? 4 and 5 would be nice, wouldn't it? Because we do have an x plus 5 over here, so if we have a 5, it could work out. So what would we want the 5 to be? Positive. Because if the 5 is positive, then they would simplify out. Because if they're on top and bottom, the same thing on top and bottom would simplify, yes? So any questions on anything we've done so far? We're good with this here? So how would we multiply these? Well, what's on top multiplies with what's on top, yes? What's on bottom multiplies with what's on bottom. So if I multiply these together, on top I'd have 3x times 1 minus x times x plus 5 times x minus 4 over, well, 3x times x plus 5 times x minus 1. Because again, we're just multiplying them together. And for us, really, when we have these sets of parentheses, well, we just rewrite them like this here. Now, with most of this here, we're not going to actually multiply this out. We're not going to use our distributive property to multiply this out. Because again, we're wanting to do what? We're wanting to simplify anything that's common on top and bottom, yes? So if I distributed it, multiplied it through, well, for me to be able to see what actually simplifies, I'd have to factor it back out, and that undid what we would have done, yes? So at this point here, a lot of this, there's no reason to distribute unless we're adding or subtracting, combining things. Because we'll try to keep the denominator as factored, because it'll be easier to simplify if there is anything in common. Now, if we look at this here, let's see what simplifies. Well, we have a few things, yes? Our 3x and 3x are on the same on top and bottom, yes? What else is the same? And x plus 5. Let's switch colors. What's almost the same? These here are almost the same, yes? Except the signs are flipped. That's weird, isn't it? So we'll get to that one here in a minute. But the one thing we can say for sure is that the 3x and 3x will cancel. The x plus 5 and x plus 5 will cancel out. So it leaves us with 1 minus x times x minus 4 over x minus 1. Any questions on this here? Now, it's really kind of strange that 1 minus x and the x minus 1 are really close, aren't they? But the difference is the signs are flipped, yes? I mean, if there was a way that I could switch the signs, kind of pull something out that would change the signs of both of them, we could eliminate that, couldn't we? Is there a number that we could pull out of 1 minus x and get the signs to flip? Because there might be a 1 that we could pull out. 1, but what kind of 1? Because if I pull negative out, if I pull negative 1 out, what happens to the sign if we pull a negative out? A positive becomes, and a negative becomes. Because if I pull negative 1 out of this here, well, the x becomes what? Because I took the negative away, didn't I? So the x becomes, well, the 1 is positive. If I pull a negative out of it, it becomes, yes? Wait a minute. Did we just switch the signs? Are they the same now? So if we have a set of parentheses that matches up, the x's, the variables match up, and the numbers match up, everything matches up, but both signs are opposite. We can pull a negative out, and it'll match it up. So now they'll simplify, leaving us with negative x minus 4. Y'all see this here. Any questions on this here so far? We good with this here? Bless you. Okay. 2 things. One, we'll focus on in a minute. The other is going to be the restrictions. Now, we do have multiple restrictions for this here, because if we look at the denominator, we have all 3 of these here, yes? Now, I was looking back at it, and again, the mathematician in me wants to list every single restriction. The homework that you're going to have does not do that. Okay? Now, what the homework is going to ask you to do is just list the restrictions that were eliminated. Okay? So for some of them, if these 2 here were the only ones that were eliminated, those are the ones they're going to want us to list. Because if anything's left over, well, we know it's a restriction because, well, it's still there. We can still see it. Does that make sense? It's almost... I was trying to figure out an example. If I'm trying to figure out, say, I'm at home and I'm trying to figure out what pop figures I have, would I still consider the ones that I have in my classroom, ones that I own? Well, yeah, I still own them, right? Even though they're not at my house, they still exist, yes? That's what they're talking about with these restrictions. So even though these 2 were eliminated out, they're gone, I don't see them anymore, I still have to list them because that makes sense. They're restrictions, right? Now, if this one here wasn't marked out, is it still a restriction? Well, yeah, but since it's still there, I can see it. They're not going to have us list it because, well, it's right here. I see it. It's kind of there. They're wanting us to list these other 2 because I don't see them anymore in the function. But it's kind of like a reminder, hey, we still have these. Does that make sense? It's almost like if you're going shopping for something, you have that mental catalog in your head. I'm not going to buy this because I already own it. That's what that is. This is just kind of a list to keep track. Hey, these are still restrictions. These is kind of what I have. I don't need to get it again. Does that kind of make sense? Now, the mathematician in me would still want to list everything, even if it's still there. We still want to list it, but the homework isn't going to have you do that, if that makes sense. Now, for us here, well, our 3x, our x minus 1, and our x plus 5, all of three of these were eliminated out because they all eventually crossed out because we only had negative x plus 4, x minus 4, negative x minus 4 left. Yes? It wasn't on bottom, anything on bottom. So we need to see what value of x is going to make these three equal 0. Yes? Well, 3 times x equals 0. What's x going to be? Because I could divide both sides by 3, what that's still going to give me? 0. The only number that I could plug in is 3 times it. What number is 0? Well, the only thing it can be is 0. Now this one here, we can add 1. X would be 1, and here we would. So for here, x cannot be 0, 1, or negative 5. Now, if you can do those in your head, that's fine. That's perfectly fine. Because if you can look and see x minus 1, what would make it 0? 1. Because 1 minus 1 is 0. Or negative 5 plus 5 would be 0. If you can do those in your head, that's fine. Do them in your head. But if you need to write them out, write them out. If it's helpful to write them out, write them out. Okay? Questions on this here? Okay. Now my other point that I wanted to make. When we're looking at this here, so we saw that we could pull a negative out of the top to make these the same, yes? Can I pull a negative out of the top to make these be the same? So let's see what happens. Well, if I pull a negative out of the top, well, the x becomes positive, yes? Well, what happens to the 1? It becomes plus 1, yes? Well, those aren't the same, are they? So if we're able to pull the negative out, both signs need to be what? Opposite. Because for this to work, since the 1 is negative on bottom, it needs to be positive on top. Since the x is positive on bottom, the x needs to be negative on top. If both signs are opposite of each other, then both terms are opposite, then we can pull the negative out. Another good rule for this here is if x is negative, there's a negative in front of the x, most likely we'll pull one out and see. It may help, it may not, but it'll make it easier to work with. Questions on this here? Okay, let's look at this one here. Well, hey, negative 5x squared, we might pull a negative out, won't we? Because that biggest term, if we factor, because there's a greatest common factor of 5x. We can agree with that, yes? Between 5x and 5x squared. Well, if I pull an x out, well, the x squared is going to give me a negative x, right? So instead of pulling 5x, why don't we pull negative 5x out? Because that might help us a little bit, yes? So 5x out of 5x would give us 1, yes? But because I pulled a negative out, it's going to be negative 1. We'll rewrite it later with those flipped. But we can write this as it here now. Well, the 5x squared, the negative is going to make it gives us positive x. Now, as I said, we'll rewrite it. We'll flip those so it looks nicer when we actually do the multiplication. But we'll leave it as this here. I leave it as this here because it's kind of easier to see how they factor. We're not flipping numbers and trying to factor at the same time. Less steps is better, especially on this here. Okay, let's look at the denominator of this here. 2 sets of parentheses. Since the 3 is positive, the signs are the same, and they're both negative because the middle term is negative. Because if the constant term or the third term is positive, the signs are the same, and they match the sign of the middle term, which would be negative. Factors of x squared would be x and, what are the factors of 3? 1 and 3. Well, those are going to work because that's the only way we can set it up. I mean, we could switch the 3 and 1, but would that change anything? Well, no. We'd still have the same things. All right, x squared minus 5x plus 6. Well, since we have plus 6, the signs are the same, and they are both negative because the middle term is negative. Factors of x squared are? Now, we do have some options with 6. We have 1 and 6 or 2 and 3. 2 and 3, yes. And if we do check it, that would work out to give us our negative 5x. Okay, how do we factor 5x? I mean, we really don't. Because it's to the first power and it's by itself, that's as simplified as she gets. Questions on this here? So when we multiply them together, really we're just putting them all on the top of the same fraction. We're putting them together in one fraction, yes? Easier is better, right? You want to see a real shortcut for this? It's real mind-blowing. Ready? I mean, that's what we're doing, right? We're just making them part of a fraction, yes? So we can rewrite them. There's nothing wrong with that. Because I'm just drawing one bar, and then we'll have negative 5x. Now, we can rewrite this here as x minus 1. There's nothing wrong with that, actually getting it x in front. But then it's just x minus 2 and x minus 3. And on the bottom, we would have 5x, x minus 3, and x minus 1. Now, what cancels out? X minus 3, x minus 1. And then 5x and, so what are we left with? And our yes. So any questions on this here? Now, what would our restrictions be? So x cannot be 0, yes. And then the 1, would it be positive or negative? Positive. Because if we look at this here, so we're seeing, what's going to make 5x equal 0? So that'd be 0. We're seeing what does make x minus 3 equal to 0? And what makes x minus 1 equal 0? And that's kind of how we see those there. And those would be our restrictions. Questions on this here? You kind of got the hang of this here? Yes? I have a feeling you're going to want it. We're going to want to do a few more of these, yes. So let's do this one here. I know I have a feeling, yeah. Would y'all be completely heartbroken if we do at least one more of these and then finish these on Monday? No? Not going to be heartbroken about that? Okay. So let's look at the numerator here. 2x squared minus 10x. So we do know there's a greatest common factor of 2x. Should I pull a negative out of this one? So what's the biggest variable? What variable has the biggest exponent? The x squared, yes? Is it positive or negative? It's already positive, yes? So if I pull a negative out, it would take it from being positive to negative. Well, then I'd have to pull another negative back out. Well, is there any reason to pull out two negatives? No, because a negative and a negative make a positive. So we don't need to pull anything out because the x squared is already positive. But we can pull out a 2x. And if I factor a 2x out of 2x squared, I'm left with 2 factored out of 10 gives me 5, and x factors out completely. So I just have 2x times x minus 5. Hey, I have a 2x squared. There's some common factors, yes, down here. Okay. Factoring x squared minus 25. This is one of our more favorite ones that we factor, yes? I think it is. Because it's what? A difference of perfect. So what would it be? X 5 and hopefully you'll come to like those because really, okay, well, 525 is 5 squared, x is, or x squared, x minus 5, x plus 5. On top of here, we have x plus 3. Because the degree is 1, it will not factor. Once we get to degree 1, we're done factoring. So, I mean, we could do that, or we can rewrite it as 2x times x minus 5 times x plus 3 all over 2x squared times x minus 5 times x plus 5. Now, what's in common on top and bottom? X minus 5 and x minus 5. So the 2 and 2, yes, and one of our x's would cancel out with one of them on bottom. But since there's 2 on bottom, x squared, we're left with 1, because it takes away one of them. So let's see what we have left after doing that. So 2's are gone, x's are gone on top. The only thing left on top is, well, hey, we do have stuff left on bottom this time, don't we? The last ones we didn't. So I would have n, and what else? X plus 5. Okay. But we do need our restrictions, yes? So the x plus 5, I don't need to do anything with. I mean, the mathematician in me would still want to set it as a restriction because that's mathematically rigorous, that's what we do. But according to the homework, we don't have to do it. Why? Is it still right there? So even if we look back at it and say, oh, okay, x plus 5 tells me x cannot be what? Cannot be negative 5. Because negative 5 plus 5 is what? 0, isn't it? It's still listed up there. Well, so 0 because of this here, right? Is that still listed there? Because if this x is 0, well, that makes the whole denominator 0, yes? So what's the only thing that's not listed here that was up here? the x minus 5, yes? So what would make x minus 5 equal 0? So here the only one that we would have is x equals 5. Now we did have one of the x's cancel out, but because we still have one left over where x is 0, they're not going to include that one. But we do have that there. Now this seems like a very tedious thing. Why would we do this here? The reason we're doing this here is because when we start solving equations, there are going to be restrictions. Because if you remember back to our systems of equations, not systems, our quadratics, and we were solving different things where we had, what was it, extraneous solutions. If you remember the term extraneous solutions, it's numbers we can solve for and get, values of x that we do get but do not work for the given equation. Like when we do absolute values, how we found values of x that work for absolute values but didn't work in the original function. That's what we would get. Now this here, what's nice is if I lift these out, especially when we start solving at the beginning, well, we know these values don't work, right? So if I was solving something dealing with this here and I got x equals 5, well, what do we know about it? X cannot be what? So if we got it as a solution, we knew it does not work because what? We said already, x cannot equal. So why is this helpful? Well, instead of me having to go back and check it, this is already telling me it doesn't work, right? So that means I don't even plug it back in. I can throw it out because, hey, no, this doesn't work. It'll make the denominator 0. So that's why this is nice, especially once we get into solving. And I don't want to rush through these here because I want to do at least one or two of these, and I want to do one of these. These aren't any harder than the ones we did before, but these are a little tricky, especially if you haven't seen them. Because where would this multiply? What number would we multiply this by? The x plus 2 or x cubed minus 27? Let's look at it in a different sense. Say 2/3 times 4. How do I multiply this? How would we multiply these here? Would the 4 be multiplied by the 2, the 3, or both? Because really, what is the denominator of 4? It's just not written in. So the same thing's true for here. The denominator of this is 1. So even though we know how to do that, it's still, because it's in a different context, I still want to look at it. So we'll finish this up on Monday.